Okay, who else there? Good morning, guys. Sudah bangun kah semua? Maka sudah bangun ah?
Sudah.
Sudah bagus. Morning, Jordan. Jaden. Morning, Alicia, Adeline, Chu Jiashuan, Ayung. Okay. Today's work going to be a pure Form 4 revision. Form 4 revision. So I'll do a Form 4 revision today. I sent to the group with the question paper. Right? Then we'll discuss that now. It's a recap of all your Form 4. So if you remember, few weeks ago, I think April, we did a revision of chapter 3. I wrote here, we did chapter 3 revision and a bit of chapter 4. Yeah. We did it, I think so, April 7, something on. April 7, something on. Okay. So today we do chapter 4 alone, revision. Okay. All in already. The problem is once I open the screen, then these people are here, I can't see. I have to come back and see. Yicheng, are you there?
Yes.
Yes, okay. There. Tisha now ni coming. Alim, selamat berpuasa. Selamat Raya, Alim. Selamat Raya, Alia. Who else is there? Nur Syahira, mana Alim? Tak tahu pula. Alia mana? Alia pun tak ada. Selamat Raya, selamat bercuti semua. But I think personally lah, since I love these Form 4 kids a lot, Form 5 kids a lot, maybe lah, later update lah, maybe I'll call you all for 1 or 2 classes lah. Can, right? Anybody want to go against me if I do any extra class? Ada meh?
Once a
Tak
week,
ada
okay
kan?
lah. You don't kasi twice or thrice a week lah. Kasi whack cow you after school reopen.
Who's that?
You better let us know like 3-4 days before. You know, don't like on the day itself. Later we have class. Later I really tell you.
Hey, on your camera and talk to me. Talk like a man, Pastor.
My
Who's
computer
that?
don't have camera lah, dey.
Ayo. Use your handphone then. Okay. I'll let y'all know lah. I'll let y'all know. Then I will inform you. Okay. All right. Let's start. So if anybody is there, they have to tell the friends and you all have to inform me lah to let them in. Okay. Now we go to the question papers I sent in the morning. Okay, let's look at this question. Okay, first question. The following figure shows part of a coffee making machine. All right. Water is heated and changes. All right, into steam. The steam is produced at 100 degrees Celsius. Okay. And is used to heat milk. The machine initially contains 500 grams of boiling water. The heater transfers 1.2 kilojoules of energy to the water every second. 1.2 kilojoule every second. All right. The heater switches off when 100 grams of water remains in the machine. So when the balance is 100 gram, the heater switches off. The specific latent heat of vaporization is 2250 joules per gram. Okay. Define specific latent heat of vaporization. Okay, let's call Marcus. Marcus, you still remember or not? Where's Marcus? Talk, Marcus. I can't read the message.
I forget already.
Forget already. Okay, let's call Jordan. Jordan. Michael Jordan.
Amount of heat needed to change liquid to gas.
Vaporization. Okay, amount of heat energy needed by 1 kg mass of a substance. 1 kg mass of a substance to change the state of matter from liquid to gas. Amount of heat energy needed by 1 kg mass of a substance to change the state of matter from liquid to gas while temperature remain constant. While temperature remain constant. Okay, next one. Done. Calculate the time for the machine to produce steam. Okay. How the machine is going to produce steam? Let's calculate the time taken. Okay, we know that the quantity of heat energy released must be equal to the quantity of heat energy absorbed. All right. The heat energy is released by 1.2 kilojoule for every second. So 1.2 kilojoule for every second, all right, is 1,200 joules for every 1 second. 1,200 joules for every 1 second. This is 1,200 joules per second or watts. So heat energy released should be PT, the power times the time. So PT must be equal to ml. This is the latent heat, right? The changes from liquid to gas. So the power is 1,200 watts. We are searching for the time taken. The mass here, all right, is 500 gram, but remaining is 100 gram. That means only 400 gram. Only 400 gram, all right, of the liquid changes to gas, all right, and the latent heat of vaporization involved was 2250 joules per gram. Can you all see something, guys? Here I'm not changing this. See, I'm remaining gram because here joule per gram. So if I solve this, what should I get? If I solve this, what should I get? Somebody calculate for me, please.
70.
Tolong kira.
750.
750. Okay, rest of you got 750. 400 times 2250 divide by 1200. Anybody else got problem? All of you got the answer? Hello?
Teacher,
Yeah.
Jishan asked you to let him enter.
Oh, okay. Okay. Who's that? Wow, so many. All waiting. Okay, done. Thank you. Okay, thank you. Next one. Those who use the coffee making machine must be careful not to injure themselves. All right. Explain why a jet of steam You know, a jet of steam, the steam comes out like spraying, you know, very fast, coming out. Okay, is more dangerous than the same mass of boiling water. Why the jet of steam is more dangerous than the same mass of boiling water? Okay, let's call Mr. Xuanzin. Are you there? Or Marcus? Not Marcus. Sean. Mock. Sean Kern. Talk. Talk. Don't type all. I can't see. Or the girls. Alicia. Anyone help me? Don't tell me you still don't have microphone. All the shops are open.
Yes.
Okay. Answer B.
The temperature of steam is higher than the boiling water.
Actually, both should have same temperature. What? Water boils at 100 degrees Celsius. Steam also will have the same temperature of 100 degrees Celsius. Try again.
Higher pressure.
Pressure can be accepted. 1 point because of pressure. Can. Lagi?
Water move freely. No.
Water
Steam
move-
move freely.
Steam move what? Steam move what? How?
In the air.
So
So it might
pressure is
reach
higher.
you faster.
Yes, the rate of exposure to the heat. The rate of exposure to the heat is higher because boiling water also changing liquid to gas, right? The steam is all in the form of gas, right? So the rate of exposure to heat is very high. So the injury will be severe. It will be a worse injury lah, all right? Because you must understand, boiling water, the content is there. It look like the same mass, you know. Maybe you kena the whole thing for 4 seconds. But this one, the steam, it's a jet. You kena in 1 second, boom, your cell exposure, the rate of exposure you kena is very fast, boom. So the injury will be maximum. And yes, it comes with a high pressure. So high pressure means you will be exposed to a high intensity of pressure, which will damage your skin also at a higher level. Any question? Siapa ada soalan? Any question, guys?
No.
Okay, thank you. Next page. Question 2. Okay, let's try this now. We all try. The energy of liquid decreases as it turns into solid at melting point. All right. So energy of the liquid decreases as it turns to solid at melting point. Okay, now. So the question is why? Okay, try, guys. Okay, let's call Mr. Tay from 5 Graham Bell. Mr. Tay? Hicheng?
Not there, man. How about me?
Yeah, lah, where is Tay? He's not answering.
Okay, sure.
Yes.
Mr. Tay, answer. The energy of liquid decreases as it turns into solid at melting point. Explain using ideas about molecules. Why decreases occur? Why? Mr. Tay, hello.
Cause freezing point and melting point is the same.
No, the question is, why decreases occur? why there's a decrease. Why there's a decrease. All right. And energy decreases as it turns from solid, as it turns into solid. That means from liquid, it's turning to solid. So what happened? Okay, who want to help him? Let's
The
call. Yes, tell.
The particles loses kinetic energy as the temperature decreases.
Can take, but they are very strict. They said at melting point. At melting point, at condensation point, they are losing energy not to decrease their average kinetic energy. They are losing energy to what?
Combine.
What happened here? Yes. So what happened here? The loss of heat energy to the surrounding, or loses heat energy, loses heat energy to the surrounding. Loses heat energy to the surrounding. Loses heat energy to the surrounding to form back. To form back forces. To form back forces of attraction. To form back forces of attraction between the particles. It's not to form back forces of attraction between the particles, because they are changing the state of matter from solid to liquid. So, liquid to solid, So, energy of the liquid decreases as it turns from liquid to solid, because they're losing heat energy to the surrounding to form back forces of attraction to change the state of matter from liquid to solid. That is why the molecules are losing heat energy. So it's if you look at the graph also like that. So first they'll be liquid. They are forming the changes at freezing point and becoming solid. Liquid, solid. So they have to lose the heat energy to the surrounding, while temperature still remain constant, but this time is to form back the force of attraction between the particles to change the state of matter. That is why their energy, the molecules' energies are decreasing. Okay, number 2A done. Number 2B. 2B, semua orang kira sekarang cepat. Semua orang kira. An ice cube tray is filled with 400 grams of water at 20 degrees Celsius. It is placed in the freezer compartment
Teacher.
of...
Teacher, there are some people waiting.
Wanted to come in.
Yeah.
Ayo, why lah? They are coming in so late, and Zoom did like this, Adila, now. I don't do anything on setting. You know, other teachers are having the same problem, right? Hello? Nigel? What is the time now, Nigel? Nigel? What is the time now, Nigel? Are you in, Nigel? Okay, the rest of you can see the screen, right?
Yes.
Okay, an ice cube tray is filled with 400 grams of water at 20 degrees Celsius. It is placed in the freezer compartment of a refrigerator, right? And the water becomes ice at 0 degrees Celsius. The specific heat capacity of water is given, and the specific latent heat of fusion of water is given. Calculate the total energy removed from the water. So it was 400 grams placed in the freezer, and it turned to be ice. So if you look at the idea of graph, it will be like that. From 20, drop to 0. And completely becoming what? Ice. So the heat energy that was removed here must be equal to mc theta while the drop occur plus ml when the changes occur. So mc theta is from 20 degrees Celsius to 0. And then the ml is 0 to 0. 0 to 0. All right. So the Q here, let's look at it here. The mass is 0. Actually, we don't have to change, because all they give in gram purposely. This question, all they purposely put in gram. So we can use that. So 400 gram. Specific heat capacity 4.2. You will see this in chemistry later, in thermochemistry. Joules per gram per degree Celsius. And the temperature dropped from 20. From 20 dropped to 0. So 20 plus the mass still 400 gram. And the latent heat also given. Latent heat of fusion also given. 330 joules per gram. Mr. Ng Ka Chen. Ng Ka Chen, sorry, Ng Ka Lo. Sorry, Ng Ka Chen is Carl's brother. Can I get the answer?
165600 joule.
Are you sure?
I calculate again.
Correct lah.
Correct.
Correct. All right, very good. Sean, Taeyang missing again today.
It's in
Is in area. Okay, very good, very good. Taeyang, how are you, Taeyang? Hi, Taeyang. Okay. Anyone got problem with this calculation? If no, means go to the next next question. Okay, next one. Next one, let's talk. Okay. A refrigerator which contains, a freezing compartment. A refrigerator which contains a freezing compartment at the top cools all of the air in the refrigerator. Explain why. We call Celine Chong. Miss Celine Chong, can you answer this for me, please? Celine Chong, a refrigerator which contains a freezing compartment at the top cools all of the air in the refrigerator. Explain why. Cannot. Miss Celine Chong, Chin Man. Kakak kepada
Yes,
Saksen.
sir.
What's the answer for C?
What is your answer? Anyone? Let me think.
Okay, think. No problem. You can ask your brother. He might know.
I don't know.
Terrible flair.
I don't know.
Okay, okay. It's okay. No problem. Okay, Alin, try. Alin. Hi, Alin. Alim.
Alim no mic je.
Ayo. Okay, Naman. Okay, let's try now. A refrigerator which contains a freezing compartment at the top cools all of the air in the refrigerator. Explain why. Okay, write down there. The cold air from the top, will have high density. The cold air always have high density. Will have what? High density. It will move down. Density increases, it moves down. Density increases, it moves down. and a convection of airflow occur. A convection of airflow occur. So the cold air goes down, the warm air goes up, and continuously what happened? The convection of air occur, convection of air occur.
Teacher,
So
can you
find-
one more time?
Okay, the cold air shows increase in density. The cold air shows increase in density. So density of cold air is higher. That means it's getting heavier lah. You know, it's getting heavier also. So it's moving down. It's moving down, and the warm air started to go up. So this is called a convection of air movement, right? So after some time, the whole refrigerator will be cool. Of course, up is still very low temperature, 0 to -2 some of your refrigerator. Down, they will maintain like 4, because the chilling part is upward. So this is the idea for this question. Okay, Tang Jiashen, are you there? Don't tell me you also don't have microphone. Sama jawab ke? So Yap Jujan is as usual not there lah. Correct, right?
Yep.
Terence is not there. Who else not there?
Alfred, Leila, Sukwe. Kavin, I think he's trying to enter.
Alfred also not there. What about the
Sir
Alfred
Kavin
lah?
asked you to let him join back.
Ah,
The connection problem.
Kavin, why he went out? Connection
Connection
problem.
problem.
No, he's not in now. I can't see him.
No, he was in just now.
Earlier was in lah. Now, okay, Kavin coming. Okay, alright. Okay, I saw him. Okay, Kavin is in. Let's go back to this page again. Okay, next one. Now, question number 3. Okay, let's try this one, all of you. Okay, all try question number 3. A and B. Semua orang try. Try sekarang. All try now, please. You must have your calculator, paper, pen, everything. Try, guys. Whose microphone is that? Try number 3. A beaker contains 100 grams of water at a temperature of 50 degrees Celsius. Okay. An ice cube is removed from a refrigerator and dropped into the water. All right. The ice cube is initially all solid at 0 degrees Celsius and has a mass of 3 grams. When the ice cube melts, the water is stirred and has a temperature of 46 degrees Celsius. Specific heat capacity of water is 4.2. But see, they're using all grams, that's why. If kilogram is 4,200. In this question, ignore the heat loss to the beaker and surrounding. Calculate the amount of energy released by water as it cools from 50 to 46. Some more try. The amount of energy released by water from 50 to 46. Okay. Let's call Giao is there. Hi, Giao. Giao, are you there?
Yes, Chair.
Okay, let's try this one, number 3. So amount of energy released, DL, should be
Yeah.
only MC theta. You know why not?
Why?
Because temperature dropping, that's all. When
Okay,
temperature
okay.
drop, only MC theta. Okay, what was the mass of water?
100.
The beaker
gram.
has 100 gram. 100 gram. I'm not changing to kilogram because the specific heat capacity given in joule per gram. So 4.2 joule per gram per degree Celsius. Okay. And then temperature 50 drop to 46. What we should write, Yao?
4.
16. Yes or not?
Yeah.
Yeah lah. Temperature drop from 50 to 46. So what's the answer, Yao?
116 one.
Isn't it 4?
50 to 46, 4 lah. Where got 16?
Yeah, 4.
Hey, yeah lah. Hey, sorry.
I thought math skill.
Bro.
They don't play my feelings, they.
I thought my math fail or
I
I
also thought my math.
brain disorder or something.
I'm checking who is sleeping and who's observing now. Only the
Yeah,
boys
yeah,
are
yeah.
observing and seeing carefully.
Yeah.
Oh,
Yeah,
the others
not
are
bad lah.
sleeping.
Your comeback. Your comeback not bad.
Very good.
Good save, good
I
save.
was testing Giao is slowly looking at the number. No?
Jiao
what's the
memang
answer,
blur
Jiao?
one. Take some time for him to realize.
What's the answer, Giao?
1680.
1680 joules. Okay. Thank you. Now we move to the next question. The melted ice from the ice cube gains energy as it warms from 0 to 46. 0 to 46. Okay. Calculate the amount of heat required for the temperature rise. Remember this, it was ice cube, then only becoming water at 46. So let's call Chek Chuan. Chek Chuan, are you in?
Yes.
Okay, Chek Chuan, see here. So the quantity of heat energy, okay, required for the temperature rise. Quantity of heat energy absorbed is always equal to quantity of heat energy released. All right. So if you remember, the question says earlier, you put the ice cube. The ice cube is placed. The ice cube is placed inside the inside the water. The ice cube is placed inside the water. So the ice cube absorbs the heat energy from the water. From where the ice cube got the energy? From the water. Yes or not?
Yes.
So heat energy release is equal to heat energy absorbed. So if heat energy release equal to heat energy absorbed, so the melted ice from the ice cube gains energy. So what is the value of the energy? Chek Chuan?
Don't know.
1680 lah.
Still same.
Yeah, that's the energy the water release. Which object absorb it? The ice. The ice cube, once you put inside water, started to absorb that energy. The ice cube, you have your beaker, right? Okay, you have a beaker, right? So this is your ice cube. So whatever energy the water gave, the ice cube absorbed already. So what's the answer, guys? Hello? 1680 joules lah. That's the answer. So what's the calculate the amount of heat required for the temperature rise? That's the one. Okay, next question. See carefully. Use your answer in A and B to determine, all right, the latent heat required to melt ice cube. What is the latent heat required to melt ice cube? Not the specific latent heat of fusion, guys. They are not asking that. Remember, they are not asking the specific latent heat of fusion, not that. They are asking what is the latent heat required to melt the ice cube. That's all. Some more orang try. Mr. Lim Ming Chun. Mr. Lim, are you there?
No.
He's not there.
Yes,
He
sure.
himself reply you no.
Hey, Mr. Lim, you're there lah. Can Mr. Lim do this faster?
Yes.
Let's try this. So Q will be equals to ML. This is the latent heat they want to know. Plus MC theta. The ice cube absorbs 1680 joules of energy. So what is the quantity of latent heat involved here? The mass of the ice cube was berapa? Ice cube of 3 gram. 3 gram. 3 gram. Specific heat capacity is still 4.2 joules per gram per degree Celsius. Temperature of the ice after melted increased from 0 to 46. That means 46. Okay, Uncle Lim. Uncle Lim, give me answer. What's the answer, Uncle Lim?
Wait, calculating.
See my Chinese. Yat leng dot say. Correct ah? Guys, okay? Okay, next.
Yeah.
All right. Okay, next we go to this one. Determine the specific latent heat of fusion. Determine the specific latent heat of fusion. Determine the specific latent heat of fusion. Okay, semua orang cuba sekarang. What we get? They want specific latent heat of fusion. So, if you see here, Q, the latent heat just now, the latent heat just now was equal to ML. The latent heat just now collected was 1100.4 joules. The mass of the ice cube was 3 gram. All right. And now you can change back to kilogram so that we get the answer in kilogram. Okay. Joule per kilogram. So it will be 0.003 kilogram. All right. So what is the value, guys? Cepat, cepat, cepat. Mr. Sean Wong, answer.
366,800.
Very good.
Yeah.
Joules per kilogram. Per kilogram. Okay, let's do the next question. Next question. Mujahid bought 2 kg of ice cubes to cool the water that will be served to his guests later. Okay, now we go to number 4. Okay, number 4. Mujahid bought 2 kg of ice cubes to cool the water that will be served to his guests later. Okay, cantik. While waiting for his guests, he should store the ice first. Yes. Which of the following, all right, material is the most suitable to keep the ice cubes frozen longer? Explain why and relate your answer to the concept of specific capacity. Let's call Sandra. Hi, Sandra.
Hello.
Are you there?
Yes.
Okay, Sandra, answer this, Sandra. Which one will you choose? Polystyrene, glass, and aluminum container.
Polystyrene.
Definitely we choose polystyrene. Okay, what is the reason we are choosing polystyrene? Why are we choosing polystyrene?
I don't know.
Because polystyrene will have a very big specific heat capacity. So changes of temperature experienced by polystyrene will be very minimum. Because remember we learned Q equals to MC theta. Because MC theta, so what happened here? When C is equal to Q M theta. So when the C increases, theta decreases. When the C increases, theta decreases. So what happened? I will choose polystyrene container and it will show a smaller changes in temperature. It is a heat insulator. Insulator, it prevents the ice from melting, or the ice can be frozen for a longer time. Yeah? Okay, next. B. After several hours, Mujahid found that some of the ice cubes has melted into water. After several hours, Mujahid found that some of the ice cubes has melted into water. Name the process. This is a very easy question. Name the process melting. And the changes involve solid to liquid. All right. The heat involved latent heat of fusion. Latent heat, all right, of fusion. Okay, done this one. It's a very easy question. Okay, next one. Let's try the next one. Okay. 0.5 kg of ice has melted. Okay. Calculate the heat energy has been used to melt the ice. 0.5 kg melted down. So it's only melting, you know. So we call Yongsin or Avril. Yongsin and Avril. The formula will be Q equals to ML. Girls, they want to know what is the heat energy being used to melt the ice. So Q equals to mass 0.5 kg. Latent heat involved is latent heat of fusion. 3.36 times 10 to the power of 5 joules per kg. Okay, now give me answer. Hello.
168,000.
168,000. 168,000 joules. Correct, class? Hello, class.
Correct.
Yes.
Very good. Okay, next we go to 168 lah. I wrote wrongly, right? Correct. I wrote wrongly lah. 168,000. Okay, done with this one. We go to the next question. Number 8. This one. What is the answer is there. First we'll see the answer. Okay, what is the final temperature? What is the final temperature What the question say? Of the ice that has been melted, if the heat of surrounding at the time is 189. What's the answer? How to do this? See here. What is the final temperature of the ice that has been melted? Ice that is melting. If the heat of the surrounding at that time is 189 kilojoules. So you must understand quantity of heat energy released is equal to quantity of heat energy absorbed. The surrounding has 189 kilojoules of heat energy. That means it's 189,000 joules of energy. When the ice is melting, ml class, after completely melted 0 degrees Celsius to 0 degrees Celsius melting, then from 0 degrees Celsius will increase to the final theta temperature, mc theta. This is the value we are looking for. Alright? Okay, semua orang kira, cepat kira what we get. Kira-kira. Semua kira. Teo Sin Yi, Sin Yi. Zizan, Sin Yi, Zizan. Try this question. Give me answer. Mr. Tam Jiashan, you also can try. Give me answer. So 189,000. The mass of the ice cube was berapa just now? It's in the earlier page. The mass of the ice cube was berapa tadi? 0.5 kg of ice. 0.5 kg of ice, 0.5 kg of ice. Okay. So this is 0.5. 0.5. This was actually this part we found just now, right? This whole thing just now we found already. This one. What was the value just now? The whole thing we found just now.
168,000.
Yeah, correct. Plus mass is 0.5. This is 4200 because now using kg. Kg. Find the theta. Okay. Okay, semua orang kira what we get, what's the answer we are getting? So this final temperature, what you are getting, guys? 189. Tam Jiashan, give me answer. 189,000 minus 168,000. Divide by 2100. 10, right? 10 degrees Celsius. That's the final answer. That's the final answer. Okay. Let's move on. Yeah.
Dear GL is waiting.
Susah loh. But why they're coming at the last minute? GL, how many more minutes only we got? Thank you. Okay, let's try number 5 now. Let's try number 5 now. A liquid at a temperature of 100 degrees Celsius is placed in a test tube. The sample is allowed to cool for 120 seconds in a laboratory where the temperature is 20 degrees Celsius. Okay. The following figure shows the cooling curve obtained. State the time when the sample becomes completely solid. According to the graph, when I see the graph, it shows me, see here carefully, it shows me a perfect here, So, here plus, sorry, where am I looking at? Sorry, here. Ini kan, ini betul-betul 90, betul-betul 95. Can you see or not? It's exactly in the middle. It's exactly in the middle. So the question now, state the time when the sample becomes completely solid. I will take 95 seconds. Right? State why the sample is losing heat throughout the experiment. Why is it losing heat? So the answer will be heat energy is transferred. Heat energy is transferred from a higher temperature to a lower temperature object. Heat energy is transferred from a higher temperature object to a lower temperature object. Since the sample has a higher temperature, the sample is losing heat to the surrounding with lower temperature. So I repeat again, heat energy is transferred. Heat energy is transferred from a higher temperature to a lower temperature. Give me another, lunchtime, right? So give me some more minutes. Let me finish. Okay, relax first, guys. Let me finish. Anybody very hungry, want to leave and run now to the kitchen? All of you at home, right?
Bang, cepat lah bro.
Faster. I'm hungry.
Started lah.
That's right. Call you faster. Finish. I'm here.
That's why I started already. Okay. Heat energy is transferred from a higher temperature object to a lower temperature object. The sample is having a high temperature. So the heat energy is transferred or lost to the surrounding. The heat energy is transferred or lost to the surrounding with a lower temperature. Okay, next one. But one more page only, guys. One more page only. Okay. Next, see here. Explain why the temperature of sample is constant for some of the time. Oh, that one very easy. The heat energy loss is to form back the forces of attraction. So when they form back the force, like the earlier question, when they form back the forces of attraction, temperature will not change. Temperature remain constant. Temperature changes when there's a changes in the average kinetic energy of the particles. So here now temperature is constant because they are losing heat energy to form back the forces of attraction. So the last two questions, I'll show you how this is solved. What is the amount of heat required to turn 2 kg of ice into water at 80 degrees Celsius. So, see carefully. Right, what you need to know here is from ice to water. So first you must know the latent heat. But this is 0 degrees Celsius to 0 degrees Celsius. Solid to liquid. Then the 0 degrees Celsius increase to 80 degrees Celsius. This one, MC theta. So ML plus MC theta. ML plus MC theta. Okay, done with that. And then you plus these two, you get the answer. So here ML plus MC theta. ML is the changes from ice to water at 0 degrees Celsius, still 0 degrees Celsius. Then the water increase the temperature from 0 to 80 MC theta. So you get the answer. Okay, last question for today lah. Calculate the time taken by 1 kilowatts heater to turn 2 kg of ice at 0 into water at 100. So same like the earlier question, you must understand two concepts here. First, the water changes from 0 degrees Celsius to 0 degrees Celsius. Okay, 0 to 0, right? 0 to 0, melting. This is while melting. Then the temperature increase from 0 to 100. 0 to 100. This is the one lah. 0 to 100. This while melting, this one 0 to 100. So the power must change to watts. Watts, cannot use kilowatts. And the time, you are searching for the value of the time. So PT is the heat energy released. This whole thing is the heat energy absorbed. So PT equals to ML plus MC theta. So all these were given. Latent heat of fusion given, specific heat capacity given. So you found the time already lah. Clear guys? That's the answer. Any question? Siapa ada soalan? Siapa budak yang lapar tadi tu? Who very hungry boy just now? Alim selamat hari raya, Lela selamat hari raya, Syahira selamat hari raya, Mr. Lim Ming Chun selamat hari raya, Taeyang selamat hari raya.
Thank you.